Hello everyone, this is Singh and today we are discussing how Discord indexes billions of messages. In last video, we discussed how these messages are stored, how these billions of messages are stored. In this video, we are focusing on how these messages are indexed, how these billions of messages are indexed. So let's start and jump right into it. So what kind of requirements we are looking for the indexing data storage? So we will need some kind of indexing technology, right? So what kind of requirements we are looking for? The first requirement is cost effective. I don't want to pay too much of it because this is the search is accessory feature. It is not my top feature which I am providing. So it should be cost effective. It should not exceed the actual storage. So we discussed that we are using Cassandra for storing the billions of messages. So the cost of, let's say, is X and the indexing solution cost is Y. So X should be greater than Y. Cool. It should be fast and intuitive. Whatever indexing solution I am choosing should be fast and intuitive. Self-healing, when we say, let's say there are multiple nodes in any of the solution we are using. So if my node goes down, it should automatically brought up, another node should be brought up on its place. I don't have to worry about it. Linearly scalable. Whenever I have a requirement, let's say I want to index more data, so I should be able to add more nodes to it easily, right? There should be not a scenario that I have to actually think of the system again, or like how actually I have to do it, or I have to figure out on my own how I have to make my solution linearly scalable. It should be built in place. Another thing is lazily index. When we say lazily index, what we mean is I don't want to index all the data, right? I want to index the data and only when it is actually searched for. So whenever whenever a particular person in a Discord server attempts to search for the first time, then I will index this data. Let's say for a particular server, the particular Discord server, when we say server, it means Discord server, right? Don't confuse it with the actual host or node kind of server, right? So for a particular Discord server, if there are let's say 100 messages and there are, let's say, 10 members, and if they are never searching for the message, then there is no requirement to index those messages, right? So I don't want to index those messages. So when we say lazily indexed, what we mean is only index the messages whenever it is required. So whenever the first requirement is met, I will index the messages, and before that I will not do it. So this is what we mean by lazily indexed. So the finalized solution was Elasticsearch. It's like a very top solution whenever it comes to our search functionality. Whenever we want to index the data and provide search functionality on top of it, Elasticsearch is one solution which comes to our mind. Another one is Solr, which was discarded because few of the reasons. One reason is you have to configure zookeeper. Zookeeper is used for node coordination, all the nodes which you have in the cluster. So let's say Elasticsearch cluster or Solr cluster. So for managing of these nodes, Elasticsearch is gen managed, so there is no extra setup required at Elasticsearch end, but Solr setup requires zookeeper. So Elasticsearch wins our case here. ES supports automatic shard rebalancing on addition removal of nodes. So this was one of our requirement, that the system should be linearly scalable and I don't have to worry about our internal logic which is happening. So whenever there are new nodes added, new like older nodes removed in case my traffic is less, or any of those kind of scenario, any scaling activity I'm doing, scaling up or scaling down, any of the rebalancing is done is automatically handled by any of the indexing solutions. So Elasticsearch will handle that internally. Structured query DSL built in. In case of Solr, you will have to use another library to get the programming accept, but in case of Elasticsearch, you can use Kibana console to query on the data which is being indexed on your Elasticsearch cluster. Previous work experience, like this could be another reason that you have already working experience in any of the technology, and if that particular technology is also meeting your requirements, then you can go ahead and use that. ES was one of the solution which Discord engineers already had previous working experience with. It was, I believe, using logging infrastructure. So in logging, we do use ELK infrastructure, Elasticsearch, Logstash, Kibana, right? So probably in some of the blogs I read that for logging they use Elasticsearch. So since there is already experience working in that particular technology, it will be easier to build another solution on top of it, right? So due to all those reasons, our finalized solution is Elasticsearch. It is getting too much messy, but I will share clean PDF with you on the GitHub, so you can refer that just for understanding purposes. Okay, so one thing was, whenever a particular data grows, like let's say, right, so whenever my messages are growing for a particular server or a particular Discord server, so the cluster size will increase, right? So, and there could be some unobserved issues when the cluster size increases. So to avoid that, like to for not foresee those issues in future, what I can do is, from start I can build my solution in such a way that my Elasticsearch cluster sizes does not exceed a particular number of nodes. Let's say I don't want to create a Elasticsearch cluster with, let's say, more than 30 nodes, right? So how can you build that solution? So how can you avoid large ES clusters as message data grows? So what Discord did was, it the logic of routing, how the data will be stored on Elasticsearch nodes and how it is sharded, is delegated to application layer. So it will not be forwarded to Elasticsearch to handle on its own. It will be handled by Discord application itself, and this will help to index messages in pool of smaller ES clusters. So whenever I will have a requirement to create a new ES cluster, I will go ahead and create that instead of growing my already existing ES cluster, right? So this is one way. Another way, multiple clusters also help you to reduce blast radius. So let's say you have multiple clusters. This is your cluster 1, this is your cluster 2. If this particular cluster goes down, then only the Discord server messages will return to this this particular Elasticsearch will be affected. Your complete search functionality will not be affected. So you are minimizing the blast radius here. Got it? So considering these two reasons, we should think of keeping our ES clusters small as possible, and also it should also meet our requirements, definitely, right? Now, how this data is indexed, when the data comes to you, how it is indexed to Elasticsearch cluster. So we have more details following up, but let's quickly go through the diagram. So messages posted real time, the messages which are to be indexed whenever when the data will be indexed, whenever our first query is being made for actual search, right? So the this is how the data indexing will work. So the messages will be posted to queue. This is your queue. It is built on top of Celery. Okay, you can think of any of the distributed queue. So the messages are pushed to queue, and from this queue we have index workers. So these workers will pull the messages from this queue. They will do two things. This, let's say this particular server 1, S1, this will do three things basically, right? First is, it will help in routing. So when we say routing, it means that on which particular cluster this data has to be stored and which particular index this data has to be stored. So it is defined as shard in context of Discord terminology, right? Don't confuse it with the shard, which is the shard of Elasticsearch. So when we say shard in term of Discord, shard means on which particular ES cluster and on which particular index. So let's say I defined as cluster ES1 and index 1. So this routing logic will determine which particular shard this data has to be stored. So this will figure out. So first pointing is done. Once that is done, I will insert the data to ES, and it will be done in bulk, right? I don't want to write the data again and again to Elasticsearch. I will write the data once I have combination of collation of multiple messages. So once I have, let's say, 100 messages, I will write them into bulk. Bulk basically means writing in batch to Elasticsearch cluster. This is the second operation we are doing. Third operation is update the Redis mapping. This we will discuss in some times. So discuss in some time, but this is the third operation we will do. Shard and given guild IDs within shard that were updated are now dirty. Key expiration 1 hour. This might sound a little bit confusing, but let's come back to this point in some time. Okay, so I hope you have understood this concept of how indexing is working. You got the messages, you got the message in your queue. The messages are pulled from the queue by the worker nodes. These worker nodes will first they will figure out which particular shard the data has to be written. By shard we mean which is the cluster, which is the ES cluster, and which is the index. Once you have figured out that, you will write the data in bulk. Okay, and this is the third operation we will do, which we will discuss in some time. Now moving forward, mapping of this Discord server's message to ES cluster plus index, which is your shard. This is your shard. Okay, now there are two layers for it. One is persistent shard mapping. So for shard mapping, where where the data is kept, it is put in Cassandra. It is your ultimate source of truth, which is the database also where you are keeping the messages. Okay, so first layer is your persistent shard mapping, another one is shard mapping cache. While ingesting messages in workers, querying Cassandra for shard could be slow operation, so cache these mappings in Redis. So this will make it faster. Cool. Now, and this we already discussed, that shard to Discord server's message when indexed first time, right? Now how this shard allocator work, this particular routing logic, how will this shard allocator work? So what you will do is you will sort use a sorted set in Redis, keep set of shards with score that represent their load. What we here, let's say you have ES cluster 1 and ES cluster 2. Now you have to figure out which particular ES cluster the data has to be written and which particular index the data has to be written. Now you are determining that basis load. What is the load on that particular index? How much data is already written on that? The shard you are figuring out for particular cluster, for particular index, how much data is already written on that. Okay, so the shard with lowest load, the shard with lowest load should be selected. Okay, and once you have actually done the right operation, you will increment the load. So whenever a new allocation comes, you will see that what is the minimum load, like what is the minimum load possible on a particular shard. So you will allocate that shard and then you will increment the load. Okay, so this is pretty simple logic which we are doing in case of routing, and this is handled by your worker nodes. Okay, this is for actually maintaining the ES cluster. So Discord uses etcd, and nodes of ES cluster can announce themselves on etcd and they can be managed from there. There is no extra configuration which was done at Discord, and it was easily managed via this. Okay, once you have indexed the data, how this will work internally, let's get some of the details which will be specific to ES cluster. So your ES cluster will be consisting of indices, and each indices will contain number of shards within it which will hold the data, right? Number of shards. Okay, cool. So these shards which actually hold the data, this shard is Lucene index, this shard is not, don't think of it as that ES clusterable index. This shard is present in ES indices, and this is a Lucene index. ES node's responsibility of data distribution with this index to a shard belonging to that index. So the responsibility of data distribution within an index will be handled by ES itself. You don't have to worry about it. Discord has its own sharding logic in application layer as described. So when we talk specifically about Discord, right, they don't create multiple shards. Why? Because they have their sharding logic it present in their application logic. So we will see in some time what is the template which is being used by Discord for indexing this data. So we will see there that the number of shards is defined as 1, because the sharding allocation logic is defined in the application itself, which is managed by Discord in their own custom logic. So if we talk about that, index contains only 1 shard because we don't have any requirement of sharding. Index replication to 1 node. So to support our node failover, you will replicate the data to 1 node. So this is your primary node, this is also replicated on to 1 node, another node. So you will have your same data present on 2 nodes. Cool. Refresh interval is 60 minutes. By default, ES cluster provides 1 second of refresh interval. Why this was increased? We will discuss that again in some time. and we will also discuss that one pending point, the third point in the worker nodes. Okay, and index contains single document type message. Cool. Message is transformed into bunch of fields containing metadata index. Let's quickly see the template which we have, and then we will, yeah, this is the template. So if you see, the number of shards are 1, and these are the fields which you have. ID is your message ID, so channel ID, guild ID is one which is being used. It helps to scope a search to a given server. When we say server, it is your Discord server, right? So to help with the scope, it is being used, and these all are the fields which are being indexed on the Elasticsearch cluster. So when we say template, right, template defines how you are indexing this data, right? So if you query for a particular index, let's say you can query with the help of ID. So if you enter the ID, right, you will be able to get the data which is being present with all these attributes present mapping to this ID. Cool. Yeah. Another important point which is specific to Discord is the message data is not replicated to ES cluster. So if you see the ES cluster, right, only specific fields are inserted or indexed onto ES cluster. We are not storing the actual messages. The actual messages are still present in Cassandra. So what we will do is, we have the mapping present, right? We have the mapping present, so we can fetch the messages from there. This will help in saving the additional disk space, so your cost is minimized. Cool. You have already, now it could be basis use case to use case. If you have a requirement to actually store the messages in Elastic cluster as well, then you can do it, right? But in this case, in this scenario, your message storage to Cassandra solves your use case, and it also don't increase the latency too much. So you can get all the metadata from Elasticsearch, and from that metadata you can actually go to Cassandra to get the message contents and fetch from there. One problem with that was, if let's say your this particular handsome user search with message hello. So if the message is if the message is present in Elasticsearch, what you can do is you can search with this message. You can highlight this particular keyword. Let's say the actual message was present was hello world, and user search with just hello. So you can highlight this with the help of Elasticsearch support only. But since your actual message is not present in Elasticsearch cluster, you will have to build this support custom on your client application. So this was easily done, and they were built like the tokenizer and language analysis were built in the client application to handle this. So like Discord was fine to do it, so you don't have to worry about that. Now how this operation works. Okay, so there was no separate search service which was being built to handle this. There was just a library created which should handle this logic which is present on worker nodes. So routing and query logic, right? So let's say you define one API to provide that search, and one API to provide that routing logic, which can be used by the worker nodes to index the data and also search for the data. Moving to another point, which was like we had 2 points remaining. Why the refresh interval is 60 minutes, why not 1 second? And another one is related to that guild ID concept. So whenever you index the data to Elasticsearch assumes that as soon as the data is indexed, you will go and search for it, right? Now it could be a requirement for my use case that I will search for that data after 1 day, or after 2 days, or after 5 days, or after 1 minute, or after 60 minutes. In Discord's case, it was 60 minutes, right? So depending on the use case, I might not require this 1 second default time, right? So I can change that. And how Discord figured out that this problem was, when they actually did this setup on pro traffic, they observed that there was high CPU increment and there was high disk usage. So what was the reason for it? Was this reason was this 1 second time interval, because Elasticsearch is assuming that whatever data you are indexing, you want to search it right away, but I might not have that requirement. And to provide that functionality to search the data as soon as it is indexed to Elasticsearch cluster, what Elasticsearch does is, for every second for across the indices, Elastic ES flushes the in-memory buffer to loosen segment and opening that segment to make it searchable. Okay? So for doing this complete thing, it will require high CPU. It is a high CPU intensive job. It has to do as soon as the data arrives. It cannot wait for it, right? So it will have to perform that operation as soon as the data arrives. And why the disk usage is more? Because you will have the tiny segments, and at that time you are not worrying about optimization, any of the space optimizations. At that time you are not worrying about that. At that time you are only worrying about that key, the data is indexed and I have to make it searchable. But once the load is reduced, what Elasticsearch internally does is it merges the amount of data into larger segments, and they are also space efficient. Cool. So if you increase the refresh interval to, let's say, 60 seconds or 60 minutes, now this operation can carry out on its own pace. Elasticsearch don't have to make the document searchable as and when this document arrives, as and when this particular text arrives. So these operations can be performed at a slower rate, which will help in reducing the CPU and also your disk space, because from start they can be space optimized. Cool. Now moving to how your search looks like. So we will find the shard. For a particular git ID, you will find the shard where the data has to be looked. So it will give Elasticsearch cluster and index. Once you have that data, you will check Redis if shard and guild ID is dirty. Why you are doing it? Your third point, which is remaining as of now. When we say dirty, what we mean is we said that we don't want to make data searchable as and when it is already available. But in case the search query comes, before that time, in that scenario, I want to refresh the interval. I want to change that interval, and this interval is managed in application layer. This interval is managed in application layer as well as Elasticsearch level. Okay, so in case the search query comes before 60 minutes, I don't want to say to user that our refresh interval is 60 minutes, so you have to wait for 60 minutes. In case that scenario happens, I want to handle it at my end. And this is your third point, which we skipped earlier. Where is that third point? Oh, this is the third point. So you are keeping a Redis mapping where you keep this data, keep this mapping, that you can figure out if the actual refresh is being made or not. So if it is not made, you can actually do it. Cool. And in case it is it doesn't you in case you don't get any search query, then ES 60-second refresh interval will be in effect. So even if there is some issue with this, ES can manage that. Cool. So this is the reason we have our extra third point and we are creating those mappings. This will help in index should be refreshed. Or not, since it is set to 1 hour, but if refresh is required prior to that for a specific Discord server, it can be achieved via the mapping we are maintaining. So the worker thread will have these 3 responsibilities which we earlier talked about, and once you have those details, you will execute the search query, and whatever results you got, you can return those results, and then they can be handled in client application. However, they have to be reflected to the final user. So this is your search query. You provided guild ID, this is your long value, this is your content, what you are searching, 𝐂𝐨𝐬𝐿, and these are your channel IDs on which you want to search for this particular message. This is all about how the data is indexed on how billions of data. What was our heading? Yeah, so how this is all about how Discord indexes billions of messages. We will meet again with more deep dives into large scale systems. Till then, stay safe. Tata. Bye bye.